Let's now take a look at declaring the other type of variable called constants. So a constant is a field within our program whose value stays the same during the complete execution of the program. We never want it to change. Hence the term constant. We can declare constants by using the constants statement instead of the data statement. And when we declare a constant, we must also assign a value to that field. When we are writing code, we can then only ever reference the constant variable, but never change the value of it. If you do try and change the value of a constant within your program, you'll usually get a runtime error. So don't try it. So let's have a look at the syntax for declaring a constant variable. The syntax is very similar to the data statement, but with a few minor differences. First of all, you have to use the word constants. Give it a name. I was supposed to say my constant one. Give it a type. And there we have it, we're done. If you want to do another one, this time we'll make it a normal integer. Very easy. Now just one thing to note, you cannot define constants for data types, X strings for references, internal tables, and structures containing internal tables. So just remember, we will come on to those data types at a later stage of this training program. To create our first program, from your SAP GUI, you can either key in transaction SE38, or you can navigate to the ABAP editor through the SAP menu tree. Go to Tools, ABAP Workbench, Development, and there you'll see SE38 ABAP Editor. Double click and execute it. Now just before we create our program, just something to keep in mind. Try and keep your programs as simple as possible. Do not make your programs any more complicated than they need to be. Now I say this because through my many years of experience with SAP, more often than not you have to pick up somebody else's program, try and understand it, and either make enhancements to it or fix bugs that have been identified sometime after it has gone live. And the worst thing in the world is opening up a program, seeing hundreds and hundreds if not thousands of lines of code with very few comments, and it just takes an absolute age to understand. I advise you all to keep things really simple. Add lots of comments into your code so that anybody else and yourself that comes to look at the program later on can easily understand what the program's doing and the flow of the logic as it's executed. It makes everybody's life just that much easier. So let's get going and we'll enter our first program name. Now remember, we have to use our own customer naming conventions. And in this case, that means we're going to start the program with the letter Z. After a Z, you can name it whatever you want. We're going to stick with the employee theme that we used when we created our table. So I'm going to enter Z underscore employee underscore list underscore 01. You notice that I used underscores just to separate the words within the program, just to make things a little easier on the eyes. Ensure that the source code radio button is selected, and then click the Create button. We're then presented with this Program Attributes window, and the first thing you need to key in is a title for your program. So I'm just going to enter some text that describes what the program does. My Employee List Report. Ensure that the original language is set to EN, which it is by default. And just something to note, the language of the program has an effect on what text entries are displayed within certain programs. You will see that the original language field has automatically been filled in with EN for English. It's important to note that any text entries you create within your program are language specific, and they can be maintained for each country by using a translation tool. Now, we're not going to be doing this right now, but it's just something for you to keep in mind. Now come down to the attributes, and you'll see the type. Click the drop down button and select Executable Program. Now this means our program can be executed without the need for us to create a transaction code. And it also means the program can be run as a background job. We'll set the status of our program to Test Program, and we'll set the application to Basis. Now these two fields are just used to help manage the program within the SAP system itself, and it describes what the programs will be used for and also the program development status. Now we don't need to touch any other field here, so leave the authorization group, logical database and selection screen empty, and make sure the editor lock field is left clear. If you do turn on editor lock, it will prevent the program being edited. That's not what we want. Leave Unicode checks active, and I suggest you always leave it active for every program you create. This ensures your program can cater for multi-byte coding. Ensure you leave the fixed point arithmetic checked, because without this, any packed decimal fields that we use within our program will all be rounded to whole numbers. And we will leave the Start Using Variants checkbox blank. We will touch on variants later on, but for now, just go ahead and click the Save button. You should be familiar with this object directory entry box, and because we're not going to be transporting our programs, just click the local object button to assign our program to our temporary development class. And now you've made it. You've finally got to the coding screen. Now let's go down and focus on the coding area. And you can see when we created our program, the first set of lines we see are comment lines. And we were presented with 7 comment lines that ideally can be used to start commenting your program. Now, comments in ABAP can appear in 2 ways. First of all, we see an asterisk at the start of a line. If you put an asterisk in there, it turns everything to the right of the asterisk into a comment. And note, it's important that the asterisk has to be in the first column. If you make it in the second column or beyond, it's no longer a comment. The other way of writing a comment is within a line itself. So we can go to the end of this report line, insert a few spaces, and when we do the double quotes, everything to the right turns into a comment. This becomes really useful so you can comment your programs line by line, or at the very least a few lines of comments for each section of your program. So let's delete that. next line of code that we see starts with the word report, and this is called a statement, and the report statement is always the first statement in any executable program we create. The statement itself is then followed by the program name that we created. Then the statement line is terminated with a full stop. Now the full stop is way beyond the end of the actual program name. It doesn't really matter where it appears as long as it appears after the program name. It could appear there, could appear halfway, could appear right at the end. Doesn't really matter. But what is important to note is that every statement in ABAP must finish with the full stop or period. This allows your statement to take up as many lines in the editor as you wish. So our report statement could in effect be like that. As long as we got the period at the end of the statement, everything will be fine. It's the period that says when the statement is finished. Now, just before we get on to writing our first piece of code, I'll just tell you about the help options. If you place your cursor on any ABAP statement, you can then press this help on button, which we discussed earlier. It'll then bring up a window automatically filling in the keyword, and all you need to do is press the continue button, and the system will display help on that specific statement and give you an explanation of what it is used for and the syntax. So I'll click the continue button, and up pops the ABAP help, and you can see it's navigated direct to the report statement and tells you all the different additions that you can add in there. And this goes for every single ABAP statement within an SAP system. Now, as with SAP, there's always more than one way of doing things. So what you can do as well is just click on the statement and then just press the F1 key. And you'll notice it misses out that first step, that middle screen that we were shown. Now, one other little tip I'll give you right now, which I found really useful when I was learning ABAP, is a new transaction. So we'll open up a new session, and this transaction is called ABAP Docu, ABAP DOCU. And this is SAP's ABAP documentation with examples. So if you navigate the tree view on the left hand side and double click on any of the entries, this transaction will give you example code that you can use to base your own code on. You can either copy and paste it into your own ABAP editor or play around with it directly here. So we can execute this code by clicking on the execute button, and the example program will run. This is a really good transaction to help you with learning ABAP because it gives endless examples of how to use the different statements. So let's go back to our program now. And what we will do is enter our first line of code. So what I'll do first is just put our report statement back to how it should look. Then on a new line, key in the write statement, followed by hello SAP world. If you've done programming before, I'm sure you'll be familiar with that statement. So have a guess what the write statement will do. It's fairly easy. It will write whatever we put in quotes to the output window. Here we're asking it to output the text, "Hello SAP World." The write statement looks very simple, and it is, but there are lots of different additions you can add to it to help format the output. We'll come to those in a little while. But right now, no doubt you're eager to see this report run and see the spectacular output. So what we'll do is first of all save our program. Once it's saved, we can then check the syntax of our program. Everything is correct. Then we need to activate the program. And once it's activated, you can see the status has changed. And then we're ready to test it. So just press the test button. And there we can see our report title and then the text we asked it to output. How good's that? You've written your first program, all with adding just one line of code. Now to celebrate, go grab yourself a nice cup of coffee or a cup of tea or whatever your preference is, because we've got a long way to go. Now you've got your first program under your belt, let's expand on the program a little bit and add in a few more ABAP statements. So let's step back to our coding screen, and what we're going to do now is access some of the data records that we created when we built our first table in the ABAP dictionary. To do this, the first thing we have to do is include the table statement into our program, and we'll place the table statement just below the report statement. So I'll create a few blank lines and I'll key in tables. Now following tables, we key in the actual table name that we created. Now if memory serves me right, I think it was Z underscore employee list 01. And then remember, we need a period at the end of the statement. Now one little thing, remember I mentioned about Pretty Printer? I like my programs to look a certain way, and I'm always formatting them as I'm going along. So what I'm going to do here is just click Pretty Printer, and we can see what's happened is the table statement, the write statement, they've been converted to uppercase, and then the actual table and program name, they were converted to lowercase. This is just my own personal preference, and if you want to play around with how the programs look for yourself, you'll be able to do that through the Utilities menu, go to Settings, and then from the ABAP editor, go to Pretty Printer, and these are the settings that I have. So automatically indent, convert upper stroke lowercase, and I want to convert my keywords to uppercase. So let's quickly review what the table statement does. When the program is executed, this table statement will create a table structure in memory based on the structure that we defined in the ABAP dictionary for our Z employee list 01 table. The table structure will contain all the fields that we created, and this will allow us to read records from the table and store them in this temporary structure for our program to use. So to get these records into our table structure, we're going to use the select statement. So we'll key in select asterisk from. Now you'll see that I do get lazy, so I like to do copy and paste quite a lot. And that's our simple select statement. And what we're saying is select everything with the asterisk from our table. Because the select statement is a loop, we need to tell our program where the end of the loop is. And we do that by keying in end select. So our loop starts with the select and ends with end select. So if this statement is now going to read every row of the table into our table structure, we need to do something with it. So what we're going to do here is just use the write command that we have used before. So I'll just cut that and paste it in. But instead of saying write hello SAP world, we are going to say write a whole row at once to the output window. So I'll click Pretty Printer just to tidy up the code. Now we have our select loop. It's going to write out every row of our table and display it to us in the output window. So let's check our code. We can see we have our first syntax error. And if you notice, the cursor has changed position and it's gone to the table statement at the start of the actual table that we identified. And it's telling us the dictionary structure or table is either not active or does not exist. So it's likely I've just got this name wrong. So all we need to do I'll open up another session, go to SE11, and we can see we actually called our table Z employees. So I'm just going to copy this name to the clipboard, close that window, get rid of the syntax error, and paste the proper table name right there. Pretty Printer again, just to format it. Now because we changed the table name up here, we also need to replace any other occurrence that we have. So it needs to be there and there. Pretty Printer again. Good. We'll save our program. Check the code. Now everything is fine. The tables are recognized and we can test our program. So click the test button or just press the F8 key. And as if by magic, our output window shows every row of our table. If you remember, we had the employee number as the first field, then the surname, then the forename, the title, and then date of birth. So if we keep the output window in mind when we go back to our code and just have a look at the select statement again, we can see that a loop happened and every row of data was written to the output window. Now let's dig a little deeper and have a look at the output window again. We can see here that the system automatically put each line from the table on a new row. The write statement that we had in our program didn't know that each new row had to be output on a new line, but this was forced because of some default settings held within our system about our own individual screen settings. Now if we try to print this report, it could well be that there are too many columns or too many characters to actually fit on a standard piece of A4. This will be determined by the width of the paper specified in the printer settings. So don't count on your output being in the right format for the reports you create. What I suggest is you use an addition to the report statement where you specify the width of each line. So if we go back to our program, if you click on the report statement and press the F1 key, you will see the line size column addition that we can add. And you can see right here, it says if the line size specification is missing, the line length corresponds to the current screen width. You can check the screen width by referencing this built-in system field, and it tells us the maximum width of the list is 1023 characters. So what we're going to do in this example is specify a line size. I'll just use a bit of copy and paste. And we'll add the addition to our report statement. We need to take out the less than sign. And in this example, let's limit the line size just to 40 characters and see what effect that has on the output. So we'll save our code, check it for syntax errors, activate it, and then test it. And there you can see the line has been broken at 40 characters in length, which I guess is right here. It didn't do a line wrap or anything like that, it just truncated the whole line. So keep in mind, if you're outputting your list to paper, normal A4 I think is 132 characters as it's specified in the help section, and if you do landscape it's even bigger, but anything greater will likely be truncated automatically. So if we did 132, and this time I'll just activate it, which automatically does the check, and I'll test. Now we're back to seeing the full output, and we can see 132 characters actually goes right up to this level here. Let's now enhance our program a little bit more by adding some specific formatting to the write statement. So what we're going to do is insert a line break at the start of every row that we output within our select statement. So first of all, I'm just going to copy this code, paste it in again. Let's just separate our table statement from our code. And we'll work with this select statement right here. So all we need to do is where we got our write statement, include the // and the / is what will trigger a new line for the write command. So let's save the code and execute it. And you can see the first select loop output the first 5 rows, the second select loop output the next 5. And look, it's identical. Why do we think it's identical? Well, it's all down to this report statement again. Because we specified a line size of 132, the system automatically wrapped the first select loop at 132 characters. So every row that was output, once it got to 132, it then caused a brand new line to be written. If we increase this, let's say 532, we should see the effect of this write statement wrapping along just a couple of rows. So let's test it out. And here we go. The first row finishes here, but then because we said we want the output to be 532 characters long, the next row was output immediately after the first one. And if we scroll along, we can see it then output the next one as well, all the way until it got to 532 characters, before it then forced another line break. So I think here it was actually the first 4 records were output on the first row, then the 5th was output on the second one. Then came our second select loop, and because we forced a line break before every row was output, they all appear correctly under one another in our report. So let's step back. I'll put this back to 132. And what we will do is add another little bit of formatting just so that we can see the separation between the different select loops. So what I'm going to do here is type uline. And uline simply means underline. If I press the F1 key, we'll see an explanation. Writes a continuous underline in a new line. So that will help separate the different select statement outputs that we have on our screen. It'll be a little easier on the eye. So if we execute this, there we go. We can see this nice underline showing us our second select loop. The next thing we'll do is just change this select statement a little bit. So we'll copy it again. I'll create a new underline. I will remove the slash before the new row is output and adding a write statement with a slash on its own, and that will mean a new line will be output at the end of the previous line. So we'll check it. I'll do a pretty printer. I always like it to look nice. Then we'll test our code and we can see a new line has been written after a row has been output. So let's go back and just change things up just one more time. This time we'll go back to the select statement with the slash Z employees like so, but we're going to include one more statement, which is skip. And skip means skip a line. And you can have an addition with the skip statement to allow you to skip multiple lines. So in this case we'll say skip 2 lines. Press the F1 key on skip just to see the help on it. There you can see skip, skip however many lines you want, or you can skip to a specific line number. So let's close the help, click Pretty Printer and execute our code. Here we go. So we're using the same select statement that we had here, the second one. Copied it down here, but we included the skip 2 lines right there. Now let's change things up just a little bit more. And this time, instead of outputting the whole row of the table, we will output individual fields. So let's create another select statement. In fact, you know what I'm going to do right now? Because we're duplicating lots of lines and it's starting to look complicated, let's add some comments. And then this one we're going to work on. Will be another basic select statement, but this time outputting individual fields. So how do we do this? Well, all we need to do is specify the individual field. So here we have the table name, and when you want to specify an individual field, you use a dash and then the actual field name. So we have surname, forename, title, date of birth, and I think the first field was employee number. So let's just choose surname. Add in forename. And then we'll do date of birth. Now, I'm not sure if I've got these field names exactly correct, so I'll just use forward navigation and check. Surname, forename, and date of birth. A stroke of luck. So now we'll do a syntax check. Everything is good. Activate our program and then test. So as we scroll down, here we go. So our first record is Brown Stephen with this date of birth, and we can see it's output on an individual line, Brown Stephen date of birth. Then the second record, third, fourth, and then fifth. So that's right in individual lines. Now let's tidy this up, because maybe we just want 3 fields on one line. So we'll take out this line break in front of the second and third field. Test it out. There we go. Just the 3 fields we want, all on their own individual line. One last thing I'll do, I'll just insert another underline just to keep it tidy. There we go. And I want to introduce something called chaining statements together. You will have noticed in our program that we are using the write statement quite a lot. Now, to save us time, we can chain our write statements together. And this saves us from having to duplicate the write statement on every line that we write. So to do this, I'll copy a new section of code. Put in some comments. And what we do with the write statement is add a colon after it. This tells the SAP system that our write statement is going to write out multiple fields or text literals as we define. So here we have write, new line, and the surname. We're then going to change the full stop to a comma. Get rid of the second write statement. Do the same with the third. Edit the code. And then when we have our last item we want to output with the write statement, that's where we put the period. So what this is basically doing is the colon says to the system we're going to output many items. We separate the items by a comma, then we use the period to terminate the statement. Very simple, and it can be used for many other statements such as the move statement. So we can execute the code. And we should see we've got exactly the same output as the one above. The only difference is we've chained our write statements together, saving our precious fingers from too many key presses. In this lesson, we're going to concentrate on creating fields in our program. There are two types of fields that we're going to be looking at. The first is variables, and the second one is constants. Before we get into the nitty-gritty, we first need to generate a brand new program. To do this, you can follow along with the steps that we outlined in the previous modules, or you can use the copy function in your ABAP editor. Personally, I like to generate a brand new program myself, but if you want to reuse a lot of the existing code, choose the copy function. And that's what I'll do right now, just to take you through it step by step. So first of all, enter your original program in the text box, then click Ctrl F5 or press the copy button. Got a window that's asking us to enter a new name for our program, and we'll just put Z employee list 02, then press the copy button. Then we're given a screen that asks us if we want to copy any additional objects. And you can see we have documentation, variants, user interface, screens, and includes. We haven't created any of these objects in the previous program, so we just need to leave those blank and just click the copy button. Assign your new program to the local object development class, $temp. And there you can see the status bar at the bottom tells you the copy has been successful. So now it's automatically put the new program name in the program text box, so just click the change button. Now one thing to note, the copy function works successfully, but you'll notice it copied across references to our old report name. So here we have a comment. So if you do use the copy function, just remember to update your comment and your actual report name itself. There we go. Now for this example, I'm just going to take away this line size statement, just so we don't come across any line restrictions while we're testing our program. Now also, because we have many select statements and write statements in this program, let's go through how we can just use the fast comment facility. So a lot of the time, I will actually delete a lot of the code out of the program, but just for demonstration purposes, I'll show you how to comment code out really fast. So normally you come in and you put an asterisk at the start of each line. There's a quick way of doing this. If you highlight the lines of code that you want to comment, then you can hold down the Control key and the less than sign, and it will automatically insert the asterisk in the first column in your ABAP editor, commenting out the line. If you can't remember your key presses, another way to do this is through the Utilities menu, and let's see if I can find it. Here we go. Under the block buffer, choose Insert Comment. Does exactly the same thing. For all the other stuff, I'm just going to delete it. In fact, I'm going to delete a lot of things. Okay, I'll save the program and then we'll get going with fields. So I'm sure everybody has a good idea of what a field is, but just so we can cover it, a field is a temporary area of memory that we can assign a name to and reference within our programs. We use fields within our program to hold calculation results. They're used by the program to help control the logic flow, and because they are temporary areas of storage, and that storage is normally held in RAM, they can be accessed super fast, which helps speed up our program execution. And there are many other uses for fields within the program, whilst creating your own programs and reading other programs created by other people. So let's have a look at variables and how we declare variables in our program. Now, a variable is a field whose values change during the program execution. Hence the term itself, variable. And there are a few rules for variables that you've got to follow. They must start with a letter. They can have a maximum size of 30 characters. You cannot include the plus, comma, colon and parentheses in the name. And you cannot use a reserved word. Now, when you are creating variables, try and keep the name of the variable meaningful. There's nothing worse than working with a program where your variables are named A1, A2, A3 and so on. Try and give them good names, such as our employee table. It's got surname, forename and date of birth. You know exactly what these fields are for. Now, we declare variables by using the data statement. So let's go ahead and use the data statement within our program. We'll go below the comments section, and the first type of field we'll declare will be an integer field. So we'll type in data, then a space, and then we'll give our field a name. I'm going to call this integer 01. Then we specify a data type by using the type word, and integers are declared by using a type I. Then we terminate our statement with a full stop. Let's declare another one, and this time we'll use the packed decimal. So I'll call the field packed decimal 01, type P for packed decimal, and then you end the statement with a full stop again. Now, packed decimal is there to help store numbers with decimal places and so on. So what we can do is actually define how many decimal places we want our variable to hold. So when we've got type P, we can then put a space and put in the word decimals and the number of decimal places we want to store. I'll put 2. Use Pretty Printer, and it converts everything how I like it, and we'll save the program. Now, we have used what are called elementary data types to define these two variables, and these types of variables have a fixed length in ABAP, so we actually don't need to declare how long the variables need to be. And a little later on, we'll have a look at all the elementary data types and the space that they take up in memory. One piece of information to note about the packed decimal is that it can store up to 14 decimal places. So in business related scenarios, that's more than ample. So as well as declaring variables this way, we have another option of declaring variables using what we call the like addition to the data statement. Let me show you how this looks. So we can declare a brand new variable . We'll call it packed decimal 02, and instead of using the word type, this time we're going to use the word like, and we're going to say like the packed decimal 01 field that we have already defined. Now, what this effectively does is make sure that the new variable called packed decimal 02 takes on exactly the same properties that we defined for packed decimal 01. Now, you may think, well, you know, what's so good about this? Well, let me show you. In the program, let's say you have a need to create a whole number of variables, all of the same data type. Here we have packed 03 and packed 04. By making them like packed 01, we could potentially save ourselves a whole bunch of time later on. Because let's say our packed 01 field, instead of saying decimal places needs to be 2, let's say we need to increase it to 3. Just by updating that one variable, then automatically updates all the other variables that have been defined using the like statement referring to our original variable. Now, another good thing about the like statement is we don't have to just refer to variables in our program. We can refer to variables, or fields in this case, that exist in tables within the SAP system. So if you remember back when we defined the Z employees table, we had a field of, I think it was surname. We can declare a new variable within our program. Let's call it new surname. And we can say it's going to be like table name, Z employees, dash, then the actual field name, which I think was surname. Now, from my many years' experience using ABAP, this saves me a whole bunch of time, because quite often you have to include numerous tables within your ABAP programs, and you can never remember what the actual data types are of every field. So just by using the like statement and referring to the actual field within the table, you can declare your brand new variables in your program without having to use your brain or go searching throughout the SAP system to find what the exact data type is. So just to make sure everything's okay, we'll just do a check. Everything's good. Now I'll just tidy things up a little bit so we can carry on. Let's get rid of that one. And those. Also, what I like to do, I always like to line up my data type declarations so it's a little easier to read. So now let's have a look at one other addition that we can add to our data statement, and that is how we declare initial values for the variables that we define in our program. And it's really easy. So in this example we have the integer 01. All we need to do is add the word value, and because it's an integer, it's just going to accept numeric values, so we can say 22, and that automatically assigns a value of 22 to integer 01 when the program starts. Now for packed decimal fields, it is very similar, but there's one slight difference. We type in the value, and then we have to put the actual value within single quotes. And this is because, as I mentioned previously, an ABAP statement is terminated by the use of a period. And for a packed decimal field that has decimal numbers, we use the period to define the decimal place within the number. Usually this would terminate our statement, but by putting the number within quotes, it's telling ABAP and the SAP system, no, we're not terminating the statement, we're just declaring a decimal number. And one little addition, just for completeness, is you're not just restricted to positive numbers. If you want to declare a negative number, just put the appropriate sign for the value of the field.